So in this video, we're going to talk about another special derivative property, specifically for the product of functions. So you might have noticed when we're looking at the different derivative properties, if I just scroll up here, we looked at a sum rule, a difference rule, and a constant multiple rule, but we didn't look at the product of two functions. When we looked at it for limits, it was pretty straightforward. It was just the limit of each individual product. But for derivatives, it's not quite the case. Okay. So in particular, the derivative of f of x times g of x is equal to the derivative of f of x times g of x. So this is just g of x by itself, not the derivative of g of x, plus f of x times the derivative of g of x. Okay. So written with the prime notation, f times g prime of x equals f prime of x times g of x plus f of x times g prime of x. Okay, just so it's a little bit easier to read maybe. So it's the derivative of the first function times the second function plus the first function times the derivative of the second function. And because of the plus here, the order really does not matter. Okay. So we can go ahead and do a proof of this. The proof it's a tiny bit tricky. You have to kind of use a technique that we haven't seen before, but it's nothing too crazy. So we'll look at the limit as h approaches 0 of, this is going to be f of x plus h times g of x plus h minus f of x times g of x all over h. Okay. So the trick here, to get it into the form that we want, is to add and subtract an extra term. So this is another common technique in proofs of things, is that you basically add a 0. So we're going to subtract f of x times g of x plus h and add that same term. So we're allowed to do this because we're basically just putting a 0 in here. These would cancel out, but it'll allow us to rewrite things all over h. So we can regroup these, and specifically we just want to break them as they are. Okay, so just the first two terms over h plus the second two terms over h, taking the limits with us. So the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x, g of x plus h over h, plus the limit as h approaches 0 of f of x, g of x plus h, minus f of x times g of x over h. So maybe you notice now that there's a term that we can factor out in both of these. In the first one, it's going to be that g of x plus h term. Okay. So specifically, this is going to be f of x plus h minus f of x over h times g of x plus h. So I'm going to factor it out, but put it on the opposite side, just to keep the terms in the proper order. And then this one, we're going to take the f of x out, and then it's times g of x plus h minus g of x over h. So now maybe you can see where this is going, right? This is f prime of x. H goes to 0 on this term, and you just have g of x. This is just f of x, right? There's no h in it. And then this whole thing, the limit of this would be g prime of x. Okay, so we get the product rule. It's a little bit long, but just inserting this one extra part, which is justified because it's equal to 0, and then we get the equality that we see up here. Okay, so let's go ahead and look at this one then. Okay, so let's look at some examples here. So let's find, let's say that we have h of x equals x squared plus 2 times 3x cubed minus 5x. Okay, so we could just go ahead and multiply this entire thing and then take the derivative, but the product rule says we don't have to. But I think we should do it both ways to kind of see if we get the same answer, right? So let's go ahead and multiply this out first. So this is going to be 3x to the 5th plus 6x to the 3rd minus 5x to the 3rd minus 10x. Okay, so h prime of x is going to be 15x to the 4th plus 18x squared minus 15x squared minus 10. Okay. Now let's do it using the product rule. So we would get the derivative of the first part, 2x, and that's it, times the second part, 3x squared, or 3x to the 3rd, right? Yeah. 3x to the 3rd minus 5x plus the second part, the first function, times the derivative of the second function. So that's going to be 9x squared minus 5. Okay. So this kind of leaves us in a uglier form, of course. So we'll have to multiply it out to see if it's the same thing. 6x to the 4th minus 10x squared plus 9x to the 4th minus 5x squared plus 18x squared minus 10. I'm starting to feel like I might have done something wrong here. But let's just keep going. So this is 15x to the 4th. I'm mostly, oh, okay, I'm seeing the second term. I just didn't combine them in this one, right? So this one actually would have been 15x to the 4th plus 3x squared minus 10. So let's see if we get that. Minus 10x minus 5 is 15 plus 18 is 3x squared. Okay, and then we have minus 10. So we do get the same thing. Okay, so in this case, maybe the first way was actually a little bit easier, but there will be plenty of times where the product rule is indeed necessary. It's also important to note this can be extended to more than 2 functions, and it will have the same general form. So like if you had f, g, and h, for example, it would be f prime of x times g of x plus f prime of x times g of x times h of x, I should say, plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. I hope I said that right, but hopefully you get the idea. Just you know, each one of the terms would have one derivative and the other two normal functions, and you'd have 3 terms at that point. And then you could extend that out to 4 or 5, etc. And because of the addition, the order of these won't matter at all.